In this video, we will talk about how to graph two variable equations. First, let's talk about the lay of the land. These graphs will be depicted on a Cartesian plane. Named after the French mathematician and philosopher René Descartes, the Cartesian plane is a two-dimensional plane which contains a vertical y-axis and a horizontal x-axis. Each of these axes contains every single real number, and they intersect at a point called the origin. They also partition the plane into quadrants. Every point on this plane has a unique location ID called an ordered pair. It's called an ordered pair because the first number always represents the x-coordinate and the second number always represents the y-coordinate. Well, at least as far as we're concerned. Also, notice how in certain quadrants, x is negative, and in certain quadrants, y is negative. So, if we are given the ordered pair 5, 4, this tells us to find 5 on the x-axis and 4 on the y-axis, and then find their intersection. You can also think of it as going 5 spaces to the right and then 4 spaces up. Okay, so now we're ready to graph an equation in two variables or some relationship between the x and y coordinates. Let's start with the simple one, y equals x plus 3. In order to graph this equation, I make a table with 3 columns. The first column being x values that I will choose to put into the equation. The second column being the y value, which results after inputting the associated x value. And the third column is the ordered pair associated with the first 2 columns. I like to pick about 5 to 7 semi-arbitrary x values. I would like for one of them to be 0, and the others to be split between negative and positive numbers. It's good to see what happens in all 4 quadrants. If we plot these ordered pairs and then connect them, we can get a general shape of the equation. It's important to understand what we are looking at. This is essentially the solution set to our equation. So these are all the ordered pairs that make the right-hand side of my equation equal the left-hand side of my equation. Let's look at another example. Y equals 4 minus x squared. Again, what I'm going to do here is make 3 columns. First column contains the x values that I will put in. The second column contains the resulting y values from inputting those x values. And the third column contains the ordered pairs derived from the first 2 columns. Let's plot these points. And now, let's connect the dots. If you are ever unsure whether you are connecting the dots in the proper order, you can simply just plug in more x values, plot more points, and then you'll get a more complete picture of what's happening. Before we end this video, I want to point out 2 major points of interest. Wherever our graph crosses the y-axis, we call that point the y-intercept. And wherever our graph crosses the x-axis, we call this the x-intercept. There can be multiple x-intercepts, however, there can only be one y-intercept. This is due to something called the vertical line test, something we'll talk about in the near future.